Good morning, students. This is Mr. Sim speaking. Today, we are going to cover some things from your Discovering Mathematics textbook. First, before the lesson begins, if you should need to pause the video, please ensure that the following materials are available. And the very first thing that you need is your notebook. You will need a calculator. You will need your textbook. And you also need your writing materials such as your pen, your eraser, etc. Now, let us begin with today's lesson. During any point in today's lesson, should you feel the need to pause the video, please feel free to do so and pause the video so that you may better understand the materials presented to you. Today, we're going to do chapter 4.2, Solving Quadratic Equations by Factorization. And this can be found on page 111 of your Discovering Mathematics textbook 2A. Okay, in general, a quadratic equation can be expressed in general form ax squared plus bx plus c equals to 0, where a, b, and c are constants. This is called a quadratic equation. Do you know the difference between a quadratic equation and a linear equation? That is correct. Okay, the difference comes from the highest power of x. In this case, if you notice, the highest power of x is 2. So here we have ax squared. Hence, this is a quadratic equation and not a linear equation. Some quadratic equations can be solved using the factorization method. So for the whole of this lesson today, we shall be learning how to solve quadratic equations using factorization. So if you cannot remember how to factorize using the frame, it will be a good time to actually revise that technique now. First and foremost, let us think about this problem here. For any real numbers p and q, if I present you with a situation where p times q is equals to 0, then I'll ask you, what could the possible values of p and q be? So in this case, we do know that any number multiplied by 0 will give you 0. So by this logic, we know that in the situation presented as such, we can say that either p has a value of 0 or q is equals to 0, because 0 times anything will give you 0. So for example, if p was 0 and q was 5, 0 times 5 will give you 0. Conversely, if p was 7 and q was 0, 7 times 0 will also give you the value of 0. Hence, when presented the product of two real numbers, p times q equals to 0, we know that either p is equals to 0 or q is equals to 0. Right, now, bearing in mind that p times q equals to 0, let us first now turn our attention to try 5 of page 111. As I've said earlier, today we will also deal with factorization. So first and foremost, let's look at the given equation here. So the given equation here is actually 3x squared plus 4x minus 4 is equals to 0. If you notice on the right hand side of the page, I've already set up the factorization frame here. So what we can do with the frame is this. First, we will fill in 3x squared and negative 4. And then we will proceed to attempt to factorize 3x squared plus 4x minus 4. So in this case, I'll write 3x and x here. Then I'll try 2 and negative 2. Now I notice that the numbers here will be negative 2x and 6x. We know that 6x minus 2x will give me the value of 4x, which corresponds to the middle value here. Hence, this factorization is correct. So now, what we're going to do here is this. I'm going to express it in the form 3x minus 2 multiplied by x plus 2 is equals to 0. If you remember from a previous slide, we know that the value of p times q is equals to 0. Just imagine that 3x minus 2 is equivalent to p and x plus 2 is equals to q. And the product of these two, p times q, actually gives me 0. So, and we know that in this case, p equals to 0 or q is equals to 0. Hence, in this case, we now know that 3x minus 2 is equals to 0, or x plus 2 is equals to 0. Then we proceed to solve. I'll say that 3x is equals to 2 and x equals to 2/3, or x has a value of -2. In this case, I know that the two values of x is x equals to 2/3 or x equals to -2. And that is my solution to this equation that we have been asked to solve in Try It 5. Now, if you can take some time, okay, to pause the video and try and attempt to put these two values or to substitute these two values into this given equation. For example, okay, if I use x is equals to 2/3, what do I notice? If I use 3 times 2/3 square plus 4 times 2/3 minus 4. If you key these values into your calculator, what do you notice? That is right. You notice that you get the value to be equals to 0, which will actually be correct. As in this equation, I know that 3x squared plus 4x minus 4 equals to 0. Do try with x equals to -2. If you put the value of x as -2 into here and here, you will also notice that you will also get the final value of 0, where 3 times -2 squared plus 4 times -2 minus 4 will also give me the value of 0. So these two values of x are the solution to this given equation. Now, using what we have learned, let us try with another question with Try It 6. Try It 6 can be found on page 112. Looking at the question on page 112, you will notice this. For this given equation down here, if you notice that the right hand side, there's a value of -49. Okay, if we compare and contrast this with the previous question, you notice that the right hand side is actually equals to 0. In this case, what should we do if we would like the right hand side to be equals to 0? So first and foremost, what we can do is to actually expand the brackets. So now if we focus on 3x times 3x plus 14, if I start to expand the brackets, what I'll get is 9x squared plus 42x is equals to -49. Notice that our aim is to get the right hand side to be equals to 0. So what I'll do now is to rearrange my equation such that 9x squared plus 42x plus 49 is equals to 0. If you notice that this form is something familiar to all of you, and what we can do here is this. Now we can start to do the factorization. So if we were to focus on our factorization frame, first and foremost, I will fill the value here as 9x squared and 49 as well. So here I will write it as 3x and 3x. Okay, 49 is 7 times 7. Here we get 21x and 21x. Again, we will test it out. 21x plus 21x gives me 42x, which shows that the factorization is correct. Hence, in this case, what we will get is 3x plus 7 times 3x plus 7 is equals to 0. So, same thing as we have done previously. P times Q equals to 0, which means that P equals to 0 or Q equals to 0. So in this case, I'll write 3x plus 7 is equal to 0 or 3x plus 7 is equals to 0. Hey, wait, let's pause for a moment. If you notice, both of them are actually the same expression. 3x plus 7 and 3x plus 7, they are both the same. So in this case, what we are actually having is something known as a repeated root. So for cases like this, when you notice that these two are actually the same, 3x plus 7 and 3x plus 7, there is no need to write them twice. So what we can do is simply to write 3x plus 7 equals to 0 once. And solving, I get 3x equals to -7. x equals to negative 7 over 3. Now, be careful here. If you notice, my final answer is given in the form of an improper fraction. That is not good. What you should do is to express it as a mixed number. Hence, my final answer or my solution in this case is x equals to negative 2 and 1/3. We shall now proceed to the next question, which is try 7 on page 112. You may like to take a few moments now to pause the video and to attempt to solve this question by yourself. I believe if you have understood the previous two examples, you have gathered enough skills for you to actually solve this question. So do pause the video and give it a shot, and I will explain it to you in a few moments. Alright, we'll come back. Alright, I hope that you have really given it a shot and tried to solve the equation here. So the first step that we should do, if you say that we should expand, that is correct. So let's expand on both sides of the equation, the left hand side and the right hand side. That will give me 15x minus 3x squared is equals to 14 minus 8x. And then now what I'm going to do is to rearrange my equation to get negative 3x squared plus 15x plus 8x minus 14 is equals to 0. Simplifying, I get negative 3x squared plus 23x minus 14 is equals to 0. Now, if you notice, in this case, there is a negative 3 in front of the x squared. Basically, the coefficient of x squared is negative 3. In times like this, it will be most prudent and it will be easier for you to factorize if you multiply the entire equation by negative 1. So basically, what we are doing here is this. Here, we will multiply by negative 1, negative 1, negative 1, and negative 1. So my equation becomes 3x squared minus 23x plus 14 is equals to 0. With a positive coefficient of x squared, in this case plus 3, it becomes so much easier to factorize. So now I will attempt to do the factorization. So here we have 3x squared and we have 14. So we'll do 3x and x gives you 3x squared. Then 14, alright, in this case, I will write it out as negative 2 times negative 7. So if I test it out down here, what I get is negative 2x, negative 21x. If you notice, negative 21x minus 2x will give me negative 23x, which means that my factorization is correct. So in this case, what I'll get is 3x minus 2, x minus 7 is equals to 0. And just as before, as we know, p times q equals to 0. So in this case, what we get is 3x minus 2 is equals to 0, or x minus 7 is equals to 0. 3x is equals to 2 and x is equals to 2/3. In this case, or x itself is equals to 7. Hence, my solutions in this case is x equals to 2/3 or x equals to 7. Alright, now we shall move on to try 8. So try 8 is on page 113. If you would like to pause the video now to give yourself a few moments to try out this question before you look at the answer presented, that will be great. If not, we shall carry on here with the solving of this equation. So the very first thing we do, once again, is to attempt to get the right-hand side to be equals to 0. But before we do that, alright, we will need to simplify, expand and simplify the terms on the left-hand side and the right-hand side. So without much further ado, I'm going to expand the left-hand side and then I'm going to expand the right-hand side. So starting my expansion, I'll get 2x squared plus 7x minus 8x minus 28 is equals to x squared minus 4x plus 3x minus 12. Then, if I start to simplify both sides, I get 2x squared minus x minus 28 is equals to x squared minus x minus 12. Then, what I'll do is to gather all my terms on the left-hand side. 2x squared minus x squared minus x plus x minus 28 plus 12 is equals to 0. If I simplify, I notice I'll get x squared minus 16 equals to 0. Now, you do remember that we will have to factorize. Do you remember how to factorize x squared minus 16 equals to 0? If you notice, x squared minus 16 can be rewritten as x squared minus 4 squared. Which algebraic identity should we use to factorize this? If you're thinking a squared minus b squared equals to a plus b, a minus b, then your thinking is correct. So in this case, if I were to start my factorization, I'll have x plus 4 times x minus 4 is equals to 0. So in this case, if you notice, I don't even need to use my frame on the right hand side. Let me just erase the frame over here. Now, I will now try to complete the question by solving. Since p times q equals to 0, I can write x plus 4 is equals to 0, or x minus 4 is equals to 0. Solving x equals to negative 4 or x is equals to 4. Now, I've completed all the examples for the lesson itself. So now, what I need you to do is to do this. Please attempt the following questions, okay, from exercise 4.2 inside your notebook. We will look through the questions in class next week. If you encounter any issues today, you may consult me via Zoom, okay? And what is the website, right, for you to use Zoom? It'll be zoom.us/join, and the meeting ID is 507-884-8172, and I will be available from the time 9:40 to 10 a.m. Of course, how silly of me, I've forgotten to actually give you the questions, and the questions are right here. It will be found on page 114, all right? And the questions that I'll need you to give a shot will be questions 2D, 2H, 2I, 2J, and question 3B. And all of this can be found on page 114 of your textbook. I hope that you have found this lesson useful and that you have learned something from this, and I look forward to seeing all of you next week.